All right, this is your lesson on vertical angles. So first thing I want to do is review some of the different types of angles that we've talked about so far in this chapter. So the first one actually isn't review. We haven't really talked about it much yet. But these are angles that are across from each other. I do think we did it one day. But angles that are across from each other, that are formed by two intersecting lines, these are called vertical angles. And that's the type of angles that we're going to be talking about today. Okay, so then this angle, I see a 90-degree angle right here. That means it's a right angle. Then right here, this is more than a 90-degree angle, but not quite a straight angle. So I know this is an obtuse angle. Then looking here, I can see that these two angles, so here's angle A and angle B, I can see that these two angles form a 90-degree angle, which means they are a pair of complementary angles. Here's an angle right here. It creates a straight line, which means it's a straight angle. It equals 180 degrees. Here's a set of angles. So here's like angle A and angle B, and I see that they form a straight line, which means they are a pair of supplementary angles. Here is an angle that is less than 90 degrees, but greater than 0 degrees. So we would call this an acute angle. And then finally, I have angles that are right next to each other that share a common ray, and we call those adjacent angles. Adjacent. All right, so today our focus is going to be a lot on vertical angles. So vertical angles are created when two lines intersect. When two lines intersect, it creates a set of vertical angles. Vertical angles are across from each other. And vertical angles are always congruent. Remember, congruent means that they're the same size. Okay, so here I have a set of intersecting lines. If I were to label these angles, I would say angle A and angle B are what we call vertical angles. Here's my set of intersecting lines. That means the angles across from each other are vertical. Not only these angles are vertical and congruent, but these angles on this side are across from each other. Those are also vertical and congruent, which means if I'm given something like what I see here, 3x over here and 45, I can actually solve for x here. I know that that angle, 3x, is the same size. It's congruent as the 45. So I'm going to say 3x equals 45. And then if I want to solve for x, I'm just going to divide both sides by 3. And I would get x equals 15 or 15 degrees. So let's try it again. Here's a set of intersecting lines. I've actually only given you one angle measure. I just gave you this one right here, 110 degrees. But from that 110 degrees, I can actually figure out the measure of the other three angles. So I'm going to start with the one that's across from it. Okay, I know that 5x has to be equal to 110 because they are vertical angles. And one thing I know about vertical angles is that they are congruent, meaning the same size. So I know 5x has to equal 110. So I'm going to divide both sides by 5. That leaves me x over here. And then 110 divided by 5. Okay, some of us might be able to do it in our head. Others of us might need to write it down. It doesn't matter. And I find out that x equals 22. So I know that the x here is equal to 22. Okay, I also need to figure out y and z. So just like in the previous video, sometimes having a Post-it note or a spare sheet of paper is handy, and I'm going to cover up part of this diagram here. And when I do that, I see that a straight line is right here. And now I have a set of what we call supplementary angles, two angles that create a straight line. So going back to what we did the last time we talked, we could say that the first angle, 110, plus my second angle, y, are going to equal 180 degrees. And if I want to figure out what y is equal to, I've got to subtract 110 from both sides. That's really bad, 110. Okay, that leaves me with y over here and 70. So I know that this y is equal to 70 degrees using my rule of supplementary angles. Okay, now I don't actually have to do any math to figure out z, because y and z are vertical angles because they're formed by two intersecting lines and they are across from each other. I know then z would also have to be 70 degrees because they're vertical angles. Pretty cool, huh? All right, so we've talked about vertical, and then there's one more thing we're going to talk about. This is called angles that share a common vertex. So an angle right here, all these angles share the same common vertex. We call these angles at a point. Okay, they all go around one central point. And the sum of these angles equals 360 degrees. If I go all the way, start here, and I go all the way around, it creates a circle, and a circle is worth 360 degrees. So let's try and solve some more problems knowing the rules of complementary angles, supplementary angles, vertical angles, and now angles around a point. So if I'm looking at this, I see that these all share a common point. They are what we call angles around a point. Okay, all the angles are central to one point. So I know that if I add all of these angles together, it forms a circle, or 360 degrees. So if I want to figure out what this x is, I could say, okay, this angle I know is 140 degrees, plus this angle right here, that's worth 84 degrees, plus this angle right here, that's 4x, and all together they form a circle of 360 degrees. Okay, and then I go back to chapter 4 and I do my solving equations. I'm going to combine my like terms first. So I'm going to say 140 plus 84 gives me 224, plus 4x equals 360. Okay, now I'm going to drop my line and solve. Here's my x, the 4 is with it, so I want to do this 224 first. And it's a positive 224, so I'm going to subtract 224 to get rid of it. So that leaves me 4x equals, I'm going to borrow here, 631. So I know 4x equals 136. So I know that this angle right here is worth 160 degrees. But I want to keep going. I want to solve for x. I can tell you right now, though, that this one will be worth 136. Now, if I want to figure out the value of x, I'm going to divide by 4. Okay, so that will leave me just x. And then I'm going to do 136 divided by 4. 4 can't go into 1, but it does go into 13 3 times, which gives me 12 and a remainder of 1. Bring down the 6. 4 goes into 16 4 times, and 4 times 4 is 16, so that's even. My x is going to equal 34. So in this case, I've done 3 things. I made an equation to solve for x. I solved for x. And then I also said that this angle measure right here would be equal to 136 degrees, kind of what we've done with both complementary and supplementary angles. Okay, let's try it again. Using our idea of angles at a point, or angles around a point, we're going to say that this angle, 2x, plus this angle, 3x, plus this angle, 170, come all together to form a 360 degree circle. So 2x plus 3x plus 170 equals 360 degrees. All right, combine my like terms first. So I have 2x plus 3x that I can combine to get 5x plus 170 equals 360 degrees. I'm going to drop my line. I see my x's here with the 5, so I'm going to do the 170 first. And the opposite of a positive 170 or plus 170 is a negative or subtract. So I'm left with 5x on this side. And then on the other side, I'm going to borrow a little bit. So 0 minus 0 is 0. 16 minus 7 is 9. And 2 minus 1 is 1. So I know 5x equals 190 degrees, but I need to solve for x. So the 5 and the x are being multiplied, and the opposite of multiplication is division. So I'm going to come up with x equals, 190 divided by 5. 5 does not go into 1, but 5 does go into 19 3 times. 3 times 5 is 15. I'd have 4 left over. Bring down the 0. 5 goes into 48 times. 8 times 5 is 40. So I know x has a value of 38. Okay, that will help me then answer the next part. So I know this angle right here is 2 x's. So 2 times x, and we know x is 38. So 38 times 2 is 76. So I know this right here is a 76 degree angle. Same thing with answering this. It says 3x. So I'm going to say 3 times 38. Maybe that's harder for you to do in your head, so you do 38 times 3. Or even if you had to do 38 times 2 this way, that's okay. So 8 times 3 is 24. 3 times 3 is 9, plus 2 more is 11. So I know that's 114 degrees. So this angle right here is 114 degrees. And if I add them all together, then I should get 360 degrees. Okay, let's try 2 more. So this one is probably a good one to have a post-it note to help you. So it says AB and CD are straight lines. So it's saying this right here and this right here are in fact straight lines. And why that is important to me is I know that means this is intersecting lines. And intersecting lines uses that vertical rule that we talked about on the front. So I can right away figure out the value of A. Since these are intersecting lines, I know that these are vertical angles. I know right away that if this one is 41 degrees, then A also has to be equal to 41 degrees. It's automatic. Since they are vertical angles, they have the same value. They're congruent. Okay? Then I'm going to use my post-it note, and I like to use it to cover up information that's not necessarily important to me to solve the problem. So I'm going to cover up that portion of the diagram. And if I want to know this angle right here, I know that from here to here is 41 degrees. I also know that these two angles come together to form a straight line. Remember, that's called supplementary angles. So I have a set of supplementary angles here. I know that this angle of 41 plus angle B together creates a straight line of 180 degrees. So if I add them together, it's going to equal 180. So I'm going to drop my line and solve. The opposite of a positive 41 is a negative 41, so I'm going to subtract 41. And in just one step, I'm going to find the value of B. So it looks like I need to borrow a little bit here. 10 minus 1 is 9. 7 minus 4 is 3. 1 minus nothing is 130 or 1. So my answer is B is a 139 degree angle. I've now solved the value of both A and B using my rule of vertical angles and then my rule of supplementary angles. Okay, let's try it again on this one. So I see all sorts of stuff going on. I have 3 intersecting lines. It says that AB, CD, and EF are in fact all straight lines. Remember, in geometry, you should never, ever, ever assume that something is straight without it being told to you. So right here, looking across, I'm going to cover up this a little bit. Here, I'm going to outline it so you can see better. here is a set of intersecting lines. And what that means is that this angle A right here is vertical to the angle that's right across from it, which is 106 degrees. So again, without doing any kind of math, I know A is 106 degrees. I can fill that in right here. Angle A has to be worth 106 degrees. Now I also want to find the measure of angle B. Now I can't use vertical angles here, even though there is a set of vertical angles. You could say that this and this are vertical angles, and going across they'd be the same, but I don't know this measure either. So that's actually not going to help us here. What I'm going to do is I'm going to take my Post-it and I'm going to cover up some information that I already, or that I don't need. So I know this right here is a straight line. It tells us line CD is in fact a straight line. So I'm going to cover up the rest of it and use the information shown to help me figure out what the value of B is. I want to figure out what this is right here. Well, I know that this angle plus this angle that I'm trying to figure out plus this small angle right here all together form a straight line, which is 180 degrees. So I could say that my first angle, 106, plus angle B, plus this tiny angle in here that's worth 13 degrees, all together gives me 180 degrees straight line. So let's combine our like terms. So I have two constants here I can combine. 106 plus 13 would give me 119, plus B equals 180 degrees. I'm going to drop my line and I'm going to solve. This is a positive 119, and the opposite of a positive 119 is a negative 119. So those will cancel out, leaving me just B. Then I'm going to need to borrow here, so that 8 is going to become a 7, and that 0 becomes a 10. 10 minus 9 is 1. 7 minus 1 is 8. And 1 minus 1 is 0. So I know angle B is worth 81 degrees. So I figured out that angle B is worth 81 degrees.